Okay, in this video we have to focus on two tasks. The one is to find the average value of the signals on the interval 0, 1. And the other one is to characterize the following signals by saying if they are increasing functions, decreasing functions, if they have minimum or maximum, and also find if they are convex upwards or convex downwards. Let's start with the first question. The average of the function is 1 over b minus a, integral from a to b, f of t dt. So the average of the first function, f1 of t, this function is e to the power of 3t plus 1. So in order to calculate the average, I have 1 over, the interval is 1, 0, 1, so from here a is equal to 0, b equals 1, so it's 1 minus 0, here the denominator. The integral from 0 to 1, e to the power of 3t plus 1 dt. So here is just this section here is just equal to 1. So I have the integral from 0 to 1 e to the power of 3t plus 1 dt is a definite integral. I can split it up. The integral from 0 to 1 e to the power of 3t dt plus the integral from 0 to 1 dt. That integral is e to the power of 3t over 3, 0, 1, plus the integral from 0 to 1 dt is just t, 0, 1. So I have to evaluate the function at the two endpoints and take away the difference, e to the power of 3 times 1 over 3 minus e to the power of 3 times 0 over 3 plus 1 minus 0. That's e to the power of 3 over 3 minus a third plus 1. So that's e to the power of 3 over 3. Then you have 3/3 minus a third plus 2/3. So f average of the first function is a third e to the power of 3 plus 2. Now let's go to find the average of the second function, f average of the second function. So it's the integral is 1 over 1 minus 0 because the interval a, b is just 0, 1 for all the functions. Integral 0, 1 e to the power of 5t plus e to the power of 3t plus 2 dt. That part here is equal to 1. So I have the integral from 0 to 1 of this function, e to the power of 5t plus e to the power of 3t plus 2 dt. I split up the integral. So I have the integral from 0 to 1 e to the power of 5t dt plus the integral from 0 to 1 e to the power of 3t dt plus the integral from 0 to 1 to dt. That's e to the power of 5t over 5, 0, 1, plus e to the power of 3t over 3, 0, 1, plus 2t, 0, 1. I evaluate each one of the functions at the two boundary points. So that's e to the power of 5 over 5 minus e to the power of 0 over 5 plus e to the power of 3 over 3 minus e to the power of 0 over 3 plus 2 times 1 minus 0. So that's e to the power of 5 over 5 minus a fifth plus e to the power of 3 over 3 minus a third plus 2. Now from here I can take common factor 1/5, so it's 1/5 e to the power of 5 minus 1 plus 1/3 e to the power of 3 minus 1 plus 2. So the average value for my second function is 1/5 e to the power of 5 minus 1 plus 1/3 e to the power of 3 minus 1 plus 2. And now I go to the other part, which is to find the behavior of these functions. So number 2, st equals, the first function is 9t squared minus 9t plus 1, 9t squared minus 9t plus 1. We calculate the first derivative of the function, that's 18t minus 9, and we take that equal to 0 to find the critical point. 18t minus 9 is equal to 0, 18t is equal to 9, I divide both sides by 9, so I have 2t equals 1, and from here I have t equals a half. That's my critical point, so for this value my derivative becomes equal to 0, and now I have to check when the derivative is positive, s prime of t greater than 0, 18t minus 9 greater than 0, 18t is greater than 9, t greater than 9 over 18, and from here t is greater than a half. And then s prime of t less than 0, 18t minus 9 less than 0, 18t less than 9. I divide both sides of the inequality by 18, and I have that t less than a half. So I have a table to make, s prime of t, s of t, and that are the values of t, and I have a t to be equal to a half. So for t greater than a half, the derivative is positive, and for t less than a half, the derivative is negative, which means that my function here is decreasing since the derivative is negative, and here is increasing since the derivative is positive. So my function s is monotonically decreasing at the interval minus infinity to a half, and s is monotonically increasing when the t is from a half to plus infinity. And I have a local minimum point, because here is decreasing and then increasing at a half and s of a half. Let's evaluate s of a half. S of a half is 9 times a half squared minus 9 times a half, 9 minus 9 times a half, plus 1. So that's 9 over 4 minus 9 over 2 plus 1, 9 over 4 minus 18 over 4 plus 4 over 4, 13 over 4 minus 18 over 4, that's minus 5 over 4. So the minimum point is 1 over 2 minus 5 over 4. And I can check if the function is convex or convex upwards, or if it's concave upwards or concave downwards, if I take the second derivative, so s double prime of t, the second derivative is just the derivative of the 18t minus 9, and this is 18, which is strictly positive. So the second derivative positive means that s is concave upwards. Now let's have a look at one more example. St is 7t squared plus 7t minus 2. We calculate the first derivative, so that is 14t plus 7, and we take that equal to 0. 14t is equal to minus 7. We divide by 14, minus 7 over 14, and t equals minus a half. Now we find s prime of t greater than 0, so we have 14t plus 7 greater than 0. From here it is implied that 14t greater than minus 7, and from here t greater than minus 7 over 14, t greater than minus a half. And also we take the case that the derivative is negative, 14t plus 7 less than 0, 14t less than minus 7, t less than a half, and we make this table again. S prime of t, s of t, and here is minus a half, minus infinity, plus infinity. S prime of t bigger than 0 when t is bigger than a half, and here I have put a minus, so it's decreasing and increasing, minus infinity to minus a half. The function s is increasing, and from minus a half it's decreasing, sorry, and from minus a half to infinity the function s is increasing, and you have a local minimum minus a half, s of minus a half, which you can calculate. And if you take the second derivative of the function, that is 14t plus 7 derivative, that's 14 greater than 0. The second derivative is positive, which means that s is concave upwards. Similarly, you can work out the third problem.